And today, we're going to dive into how we approach authentication in our applications. So let's roll up our sleeves and start coding. Head over to console.firebase.google.com and click Get Started to create your Firebase project. In the next window, you'll need to give your project a name. Let's call it Cachewise. Accept the terms of usage and click Continue to proceed. Next, enable Google Analytics for this project and click Continue. You'll then be prompted to provide your location and accept some additional terms and conditions. Once done, click Create a Project. It might take a moment, but once the project is ready, navigate to the Authentication section. Here, you'll be asked to add the sign-in methods you want to enable in your app. We'll start with Google and later enable anonymous sign-in. When selecting Google, toggle the switch to enable it. Provide a support email to proceed. Expand the Web SDK configuration section and copy the web client ID. Keep this ID safe, as we'll need it later in this tutorial. Now let's add a new Android library module. From the last video, we already have some modules in place. This time we'll add a new module named Network Firebase-Auth. Once the sync is complete, go to Tools and select Firebase. This will open the Firebase Assistant window. While there are several options available, such as integrating analytics, real-time database, and Cloud Firestore, we'll only focus on authentication for now. In the next window, click on Connect to Firebase. This will take you to your browser where Android Studio will attempt to establish a connection with Firebase. Once the connection is successful, close the browser window and return to Android Studio. You'll notice that the google-services.json file has been added to your app module automatically. We won't proceed with the remaining steps in the Firebase Assistant since we're working in a multi-module project and not a single repository. Instead, we'll manually add the required dependencies to our targeted module, ensuring a clean and efficient setup. Let's keep going. Sign in with Google is a 4-step process that ensures seamless and secure authentication for your app. First, the user taps a Sign in with Google button in your app. Your app leverages the Credential Manager to present sign-in options to the user. This is achieved by creating a Get Google ID option and a Get Credential request. The user then selects a Google account from the available options. Upon successful authentication, your app receives a Google ID token credential containing the user's Google ID token. This token is essential for verifying the user's identity. Your app then sends this Google ID token to Firebase Authentication. Firebase acts as the trusted intermediary, handling the validation process. Lastly, Firebase verifies the token's validity. If successful, it creates or signs in the user within your Firebase project. Firebase then responds with an acknowledgement in the form of a task completion specific to Android. Let's start making some changes to our code now. Update the libs.version.toml file. The version section defines version references for libraries such as Firebase Auth, Google ID, and credentials. The libraries section maps these versions to the respective library coordinates. The plugin section configures the Google Services plugin, which is essential for integrating Firebase into the project. Next, update the project build.gradle.kts file. Add the Google Services Gradle plugin in the plugin section as a build dependency. The apply false directive ensures that the plugin is not automatically applied to all subprojects, giving you control over its application. Because let's face it, no one likes plugins running wild on their own, right? Next, update the app module build.gradle file. Add the Google Services plugin to the app module. This plugin is required to parse the google-services.json file, which contains essential configuration details for Firebase services, including authentication. Up next, let's update the design system build.gradle file. Include dependencies for Android X credentials and Google ID. Now, update the Firebase Auth module build.gradle file. In the Dependencies block, integrate Firebase Authentication and Google Identity for managing user authentication. Add Coin for dependency injection and include the common module for shared logic. Lastly, update the onboarding feature data module build.gradle file. Include the Firebase Auth module we just created. This ensures the onboarding feature has access to Firebase authentication for seamless user sign-ins. With these updates, we've completed setting up the build.gradle files. Everything is now configured to support Google sign-in and Firebase authentication. Let's go. Next, let's create the sign-in error class in the common module. The sign-in error is a sealed interface with three possible error types. Invalid credentials indicates that the provided credentials are incorrect. Invalid user represents a scenario where the user does not exist or is invalid. Uh, Unknown error captures any unforeseen or unspecified errors. Using a sealed interface ensures that all possible error types are known at compile time. This allows for exhaustive when expressions, preventing the addition of new error types outside the defined scope. Next, let's add some strings to the onboarding presentation module's strings.xml file. Remember when I asked you to save the web client ID? Now it's time to use it. Create a strings.xml file in the design system module and add the client ID there for easy access. In the second video of this series, we created the Google button. Now we'll continue to update it. The onSuccess parameter now accepts a credential object instead of a unit function, making it more specific and useful. The Credential Manager is created using the current context. This initializes and configures the Credential Manager to handle authentication or authorization operations related to user credentials efficiently. Inside the C2 button's onClick lambda, a Get Google ID option is built with specific settings to define how Google credentials will be handled. A Get Credential request is created using the Google ID option to initiate the credential retrieval process. A coroutine is launched within the onClick lambda to handle the asynchronous credential retrieval process seamlessly. The credential is requested using manager.getCredential, and the result is passed to the onSuccess callback if the operation is successful. If an exception occurs during the process, the error message is passed to the onFailure callback. Next, let's create the Authentication Helper class inside the Firebase Auth module. The Authentication Helper class provides a convenient way to access the current user's information from Firebase Authentication. The getCurrentUser method retrieves the logged-in user's display name and profile picture URL, wrapping them in a custom user object. If no user is logged in, it returns null. The sign-in anonymous function in Authentication Helper uses Firebase's anonymous authentication to sign in users without credentials. If the sign-in is successful, it returns authconfig.authenticated. If it fails, it returns signinerror.unknown_error. The result is wrapped in an either type. Let's learn about either in Arrow Kotlin. Either is a functional data type used for error handling and represents computations with two possible outcomes. Either.left represents errors or failure cases. Either.right represents successful outcomes or valid results. This approach makes handling both success and failure scenarios much cleaner and type-safe. The sign-in with Google function uses a Google ID token to authenticate with Firebase. If the authentication is successful, it returns authconfig.authenticated. For failure scenarios, it returns specific sign-in error types, such as invalid credentials or unknown error. Run catching is a higher-order function that encapsulates a block of code that might throw an exception. It returns result success with the value, or result.failure with the exception. Get or else provides a clean, functional way to handle both success and failure cases. If the code executes successfully, it retrieves the result. If an exception occurs, it falls back to a default value or logic, avoiding traditional try-catch blocks. This coin module defines dependencies for Firebase authentication. It provides a single instance of Firebase Auth and an authentication helper, which utilizes the Firebase Auth instance. The Auth repository interface establishes the contract for authentication operations. It offers a property to access the current user and two suspend functions for signing in, one using a token and another for anonymous sign-in. Both sign-in methods return an either type, representing either a successful auth config or a sign-in error, ensuring clear and consistent error handling. The auth repository impl class acts as a clean wrapper for the authentication helper, providing a streamlined interface for authentication tasks. It includes methods for retrieving the current user, signing in with Google, and anonymous sign-in. By delegating these operations to the helper, it abstracts away the implementation details, improving the modularity and readability of the authentication logic. The onboarding data module defines dependencies for user preferences and authentication. It creates singleton instances of auth repository impl, binding them to their respective interfaces, and incorporates the Firebase module for additional Firebase-related dependencies. We created the event sealed class in the last video, and now it's time to update it. The event interface has been expanded to include new events for Google Sign-In and Anonymous Sign-In, allowing for more granular and specific user actions. Furthermore, a new effects interface has been introduced to handle navigation and error display. This separates UI effects from events, creating a clear distinction between state management and UI interactions. Moving to the onboarding view model, we had been handling 2 events in the last video. In this update, we've implemented several key changes to enhance its functionality and improve error handling. A new dependency, the auth repository, has been added, signifying that the onboarding process now includes authentication-related tasks. We've introduced a mutable shared flow of effects, which is exposed as a read-only shared flow. This addition plays a crucial role in handling side effects reactively, allowing one-time events or effects to be emitted and observed by the UI. This approach improves the responsiveness and clarity of user interactions. The new Get Error Message function maps sign-in error types to user-friendly UI text objects. Let's manage the Sign-In with Google event, which we recently updated. The function uses Google ID token credential to process the Google ID token, leveraging the Credential Manager API for secure authentication. The auth repository.signin method is called with the ID token, implementing a robust server-side verification process. Upon successful sign-in, the user's authentication config is saved using preference repository. The view model then emits its effects through a shared flow, enabling reactive UI updates, such as showing error messages or navigating to the home screen. Similarly, let's update the sign-in anonymous event. When this event is triggered, it calls auth repository.signinAnonymous within a coroutine scope. The view model scope plays a crucial role here. This special coroutine scope in Android automatically manages the lifecycle of coroutines within the view model. It ensures that all launched coroutines are canceled when the view model is cleared, preventing potential memory leaks and simplifying asynchronous task management. Next, we'll update the sign-in screen composable by integrating the onboarding view model using Coin's dependency injection. The introduction of launched effect creates a robust mechanism for handling side effects, allowing the UI to reactively respond to state changes emitted by the view model's shared flow. We've refined the sign-in composable to accept a dispatcher function, implementing a unidirectional data flow pattern. The Google Sign-In button now dispatches an event.signin with Google event when successful, passing the credential to the view model for processing. Similarly, the Guest Sign-In button, which was previously used for navigation, now triggers an event sign-in anonymous event. These changes reflect a shift towards a more event-driven architecture, where UI interactions are translated into events that the view model can handle. All right, it's time to put our app to the test. We'll start by demonstrating the error scenarios for Google Sign-In. For this, we'll use an emulator that doesn't have Google Play services installed. When we try to log in, it will show the error banner that we created in our second video series. Next, let's try the anonymous login. If it is successful, we should see the entry appear on the portal. Now we'll move on to testing successful sign-ins and attempt to log in. If everything is smooth and functioning correctly, we should see our user entry on the dashboard. It's great to see both Anonymous and Google Sign-In working flawlessly. Thank you for joining us today. If you found this video helpful, please give it a thumbs up and consider subscribing for more content like this. We'd love to hear your thoughts, so feel free to leave a comment below with any questions or feedback. Your support means a lot to us, and we can't wait to see you in the next one.